All right, welcome back to our AP Calc notes. Here's example 2. So our first derivative test tells me that if f prime changes from positive to negative, then we have a local maximum. If it changes from negative to positive, we have a local minimum. If it changes from positive to positive or negative to negative, there's no local max or local min. So let's take a look at a few key ideas here. Let's go back to our example from above, from the last page. I'm going to copy this. Zoom in. So here's what we're looking at. If I go from a positive slope to a negative slope, I have a max. If I go from a negative slope to a positive slope, I have a min. So let's check the first one. I went from negative to positive. That means I was going down, now I'm going up. So if I went from negative to positive here, that must mean I have a local minimum at x equals -1. Okay, what about my next part? I go from a positive to a negative, from increasing to decreasing. So I go from increasing to decreasing, positive to negative. That means I have a maximum, I have a peak at the top. So this means I have a local maximum at x equals 0. And then our last one, I went from decreasing to increasing. So I went from going down to going up. That means I have a minimum at x equals 2. All right, I'm going to ask you to make this same table, do the same thing for example 3. I'd pause the video, try it, and then unpause and check your work. All right, so let's make that table. And we're talking from 0 to 2 pi, so from 0 to 6.28. So I should have, if I take the derivative of 2 or x plus 2 sine x, I'm going to get g prime equals 1 plus 2 cosine x, first times the derivative of the second, plus the second times the derivative of the first, which is 0. So it should be 1 plus 2 cosine x. Okay. So I want to find the local maximums and local minimums. I want to know, when is this equal to 0? Well, that's also the same as saying, when is cosine x equal to -1/2? And I can solve that by doing, my cosine inverse, or I can look at the graph here. It's going to be at 2 pi over 3. and at 4 pi over 3. So at 2 pi over 3 and 4 pi over 3, I've got these critical points. 2 pi over 3, 4 pi over 3. And let's make this table I'm just going to copy and paste it. We've got fewer intervals to think about here. So we're talking about our interval from 0 to 2 pi over 3, and from 2 pi over 3 to 4 pi over 3. And I want to know, is f prime positive, negative, or 0? And then what's happening to my function. So in this case, if I were to plug in, I don't know, let's say pi over 2. If I said, what's f of pi over 2? I'm going to get a positive. If we say x equals pi over 2, I'm going to get a positive value, positive 3.6. So what's happening? F is increasing. If I plug in, well, between 2 pi over 3 and 4 pi over 3, if I plug in pi, what if I say x equals pi? Well, if I just say x equals pi, that's 3 pi over 3, which is somewhere in the middle. Then what's going to happen is I'm going to get a negative value for f prime. I get a negative 1 for f prime. F prime of pi is negative 1. So this is decreasing. So what happened? If I went from increasing to decreasing, then that must mean that I have a function that looks like this. I went from an increasing to decreasing, so I have a local maximum